Hi, everyone. Sorry about the slow start today. Obviously, you can see we had some technical difficulties, but our regular presenter, Doug Wydell, is trying to get on board here, but we'll start without him so we don't have any more of a delay. Today, we're talking about the Campbell Selection Guide, commonly known as the Pressure Ratings Guide as well. We're going to talk a lot about stamped information and some of the testing surrounded and how you can use it to your success in the field. So, as I said, I'm not Doug Wydell. I'm Rob Trifaldi, the Vice President of the Industrial Group for the Ideal Trident group that now is Ideal Trident, ZSI Foster, and Campbell Fittings. We are going to talk about the correct use for the Campbell Selection Guide, the stamped information, the engineering test reports, and how to use temperature derating. So one of the things that I think a lot of people try to figure out is how big of a deal is it when there's an accident? And one of the most common type of uses for the spill water chart is trying to figure out, well, how long does it take to fill a swimming pool? Well, you know, unfortunately, the swimming pools are pretty large, and it would take a pretty large hose with a fair amount of PSI pressure to fill that for a long period of time. But, you know, trying to boil it down to something a little bit more manageable and something that's a little bit easier for all of us to figure out is taking a look at just the standard keg and how little actually liquid is in that. And the truth is that a standard keg will actually fill, you can have a spill of a 2-inch hose of 150 PSI, and it will spill more than a keg of liquid in 2.2 seconds. So while we talk about, you know, an 8-inch hose taking only a few minutes to fill a backyard, you know, something that is just as small as a 2-inch hose at 150 PSI will spill more than a keg worth of liquid.
Hey,
Rob.
Oh, it sounds like maybe Doug is back. Doug, are you there? Can we hear you?
I am here. I'm here. Thank you for getting started.
No problem. I was talking about one of my favorite topics, a keg of beer, and unfortunately I just got into a circle talking about beer. So maybe you should take over and we should talk about some of the more business-like parts of your presentation.
Excellent. I did interject the beer example because it's pretty easy to remember. That keg of beer is going to hold 15.5 gallons, and just a 1-inch hose at 100 PSI is going to spill a keg of beer in 15 seconds. So we want to talk about avoiding an EPA nightmare. This spill rate chart is available at campbellfittings.com. And the other example, that swimming pool with a 3-inch fitting or 3-inch hose at 200 PSI, you're going to spill 1,621 gallons per minute. So that 16,000 gallon pool that we showed on the previous slide is going to be gone in 10 minutes. So that's why selecting the correct fitting is so important. We want to make sure we get the right fitting for the job. Okay, we can go to the next slide. So again, another chart we have on our website, the dynamic force chart. And this is just to show an example of why it's so important to have, again, the correct fitting for the job. It says here that a Mike Tyson punch has a dynamic force measured at 1,800 pounds per square inch. And one of my favorite Mike Tyson quotes is, "Everyone has a plan until they get punched in the face." Well, we don't want anybody getting punched in the face. We don't want anybody getting hit by a fitting that has ejected at 1,800 PSI. We want to avoid OSHA issues. We don't want EPA issues. We don't want OSHA issues. Using the right fitting for the job is what this is all about. As you can see, a 4-inch fitting, a 4-inch hose at 150 PSI is the same pounds per square inch force as a Mike Tyson punch. So we don't want that to happen to anybody out in the field. And even if you take a quick look at a 3/4 inch hose at 150 PSI and you find that intersection, it's going to show 66 pounds per square inch. Even an air hose that decouples accidentally and it's swinging around wildly, if that hits you in the head, it's going to do some damage, possibly kill you in the wrong situation. Okay, Rob, let's go to the next slide. So how do we determine our ratings? Well, first of all, you need to know that we do extensive hydrostatic burst testing, and we do adhere to the ASTM D380 standards. And all the ratings that we have on that coupling selection guide on that front page are going to be rated at 70 degrees Fahrenheit. And each one of those is going to have a safety factor of 4-to-1, typically. And some are going to have a 10-to-1 safety factor, and that's steam hose. And also there's a 3-to-1 for water hose rated below 150 PSI. So what do? We spend a lot of time testing. Next slide, please, Rob. Testing, and more testing. We prove out our published pressure ratings and pressure D ratings, and they're proven in the field, and they've been working for 20 plus years. We're very confident in them. Here you have a slide of our head engineer, Randy Kramer, conducting a hydrostatic burst test at one of our crimpnology classes. And I know quite a few of you have been up to Boyertown for our crimpnology 101 classes, and I would encourage you, if you have an opportunity to get there in the future, please take advantage of that. We will walk you through how to better sell crimpnology, and you'll actually get a chance to build a hose. You'll get a chance to blow a hose up, and that's what's happening in that slide on the left with Randy there. Next slide, please, Rob. So here is one of the tests that was prepared by Randy. And here we're trying to prove out, in this particular case, a 3/4 inch Conitech yellow nitrogen hose, which is rated at 300 PSI max working pressure and a max temperature of 210 degrees Fahrenheit. The ends are the bows, male and female ends, attached with a light duty ferrule. And you'll see that they even go through recording hose measurements. So with crimpnology, we are all about measuring the hose wall thickness. And so you can see his measurements there, and he comes up with an average. And that average, he looks up on the chart, and he gets a crimp diameter on N1 of 1.113 inches. He does the same for N number 2, and he actually has the same crimp diameter. You can see that they took this test up to 1,538 PSI before the hose failed with a gash 2 inches below the ferrule at N number 2. So this is what we do all the time. We have hundreds of these tests. Not sure we can get up to 1,000, but we're pretty darn close. And this is a great time to let you know that when you're out in the field and you've got a customer that you're trying to convert to perhaps a different hose than what they're currently using, you can send us a sample of that hose. We will produce one of these tests for you with our fittings. And I don't think there's anything better you can do than to go back to your end user and say, well, here's this hose I want to sell you for this particular application. And here's the hydrostatic burst test results with the exact fittings I want to use on it and the exact hose. It's going to go a long way to help you win business. Next slide, please, Rob. So here is the document we're going to be talking about today, the Campbell Fittings Coupling Selection Guide. And this is available on our website, but also through your regional sales manager, campbellfittings.com. You can find a hyperlink there on campbellfittings.com. You can download this so you have it electronically, or contact your regional sales manager and we'll get you some printed versions. But I have a zoomed in version on the next slide, please. So here we go. Number one thing to keep in mind is that each one of these ratings is going to be at 70 degrees Fahrenheit. So very quickly, we can look at the first section, the combination nipples. I'm not sure if you can see my cursor, but the combination nipple with a short sleeve on a rubber hose. it's going to be, we're going to have a rating for each size that we make. Well, let's concentrate on 2-inch right now. That's going to be rated at 225 PSI with a 4-to-1 safety factor at 70 degrees Fahrenheit. If you jump down to section B, the crimpnology nipple, the crimpnology nipple in 2-inch on a chemical or rubber hose is going to have a ferrule attachment. And that mechanical interlock, that attachment gets you up to 300 PSI versus 225. So as soon as you introduce a ferrule, you're going to get higher pressure ratings. And great to point out that each one of these sections is a lighter shade than the darker and lighter. This is going to correspond with our catalog sections. Section A here for combination nipples, section B for crimpnology nipples, section C for cam and groove, and so on. So a very quick reference to help you find the right fitting for the job. Next slide, please, Rob. So this is page 2 of the coupling selection guide, and the main thing here is the temperature D rating. We're going to talk about that later in the presentation, and we're going to go through some examples. We're going to make you use your calculators, and we're going to do a little bit of math so you get comfortable with derating your hose system. Below that is an example of our crimp chart and how to find a crimp spec. We're not going to do that in this webinar, but I highly encourage all of you to check out the crimpnology webinar we have. I believe Tommy Papp is doing those, and please check our latest email that went out by Courtney, and you'll see a schedule for those webinars. Next slide, Rob. So again, another test that we have here. This one happens to be a chemical hose, a 2-inch Goodyear Viper chemical hose rated at 200 PSI. We're testing this with our Campbell Cobra stainless part C and E. Now our cam and groove, our Campbell Cobra stainless C and E is in 2 inches rated at 250 PSI, and you'll notice that this hose is rated at 200 PSI. So the goal here is to burst the hose beyond 4-to-1, which would be 800 PSI. Always keep in mind that between your fittings and your hose, whichever of the two is rated the lowest is all you can rate that hose system for. So it's always going to be the weakest link. So we're going to attempt to burst this hose above 800 PSI. You can see the results. We burst the hose at 1190 PSI. So we got it well above the 4-to-1 safety factor. It's actually above 5-to-1. Next slide, please, Rob. And here's just some abbreviated reports. That's going to be that last page of that coupling selection guide. So some quick references for other fittings. And again, we have tests. We have the full-blown tests. If you need to see them, we can get those to you. Just keep these. These are great references, though. All right, Rob, we can go to the next slide. So what we're going to do is we're going to walk you through how to use this coupling selection guide. And it's so easy that somebody who's just on the job can use this Campbell Fittings Coupling Selection Guide and find the right fitting for the job. So first thing you always want to do is collect your stamp data. And this particular example is going to be a 2-inch chemical hose. The temperature, as your customer tells you, is ambient. Well, everybody's ambient is a little bit different. Part of my territory is Louisiana, so South Louisiana is going to be a lot different than upstate New York for ambient temperature. So always make sure you know what you're dealing with, whether it's the atmospheric temperature or the temperature of the media moving through the hose. But for this example, we're going to assume 70 degrees Fahrenheit. So we have a chemical transfer, and the pressure is going to be 200 PSI. We need some male threads, and of course, we need it delivered as soon as possible. So like I said, this person who's new to the job can figure out what works for them by using our coupling selection guide. Next slide, Rob. He's got a bright idea. He's going to use the Campbell Fittings Coupling Selection Guide. First step is going to go to the 2-inch hose column. Keep in mind, we want to find a 200 PSI fitting on a chemical hose with male threads. So he's in the 2-inch column. Right away, he sees 225. Oh, that might work for his 200 PSI hose. So he reads across, and oh, this happens to be a rubber hose. He needs a chemical hose. So that's not going to work for him. So he's going to continue down. 225 again, but it's the suction coupling on a rubber hose. That's not going to work. 300 psi, that's rubber hose, ball and socket. That's not going to work. Here we go. 300 psi, chemical or rubber hose, criminology nipple attached with a ferrule. Well, that's going to be result number one. That's one fitting he can use. Continue to read on. A long criminology nipple is rated at 1,000 psi, but this particular one is a rubber hose. So we're not going to use that for this example. A long criminology swivel, but on a chemical or rubber hose, or a long ferrule rated at 500 psi. Well, that's going to be one of our options as well. So that goes into the results column. And we continue down, and we have one more. The 250 psi chem joint nail stem attached by a ferrule. So you have three results. So you have three options to provide this customer. All of those would be in stainless steel, which is what you're going to need for a chemical hose. More than likely, you're going to end up with criminology nipple, unless you actually need a swivel in this case. Criminology nipple is going to be more than likely the best answer for you. Next slide, please. All right, so now we're going to do elevated temperature. So now our newbie is really confused and he's worried, but he says, I'm going to go back to that coupling selection guide and I'm going to turn to page 2 because that's where that elevated temperature stuff is. So all the stamped information is going to be exactly the same except for temperature. So the only thing we're changing here is the temperature. It's going to be elevated to 200 degrees Fahrenheit. So Rob, next slide, please. We're going to utilize our stamped data and follow the same steps as we did before. We have the same results, but we have one more big step to do. We have to account for the elevated temperature of 200 degrees Fahrenheit. So we turn to our temperature derating chart. Next page, Rob. Here we go. First thing you want to do is locate the hose type. So let's point this out that we have a rating for steam, hot tar, and asphalt. We also have another rating for PVC hose, and then all other. All other is going to be your chemical hose and your rubber hose. So in this situation, we're dealing with a chemical hose. So we read across the top line, again, at 70 degrees Fahrenheit, there's no change. The multiplier is always going to be 1 because all those ratings on page 1 of the coupling selection guide were done at 70 degrees Fahrenheit. So there's no change. But then you have 90, 150, and 200 degrees. Our example is 200 degrees. Find that intersection for the chemical hose or the all other hose, and your multiple is going to be 0.42. So a chemical hose at 200 degrees Fahrenheit has a derating factor of 0.42. Rob, can you advance, please? So criminology nipple, 300 psi at 70 degrees Fahrenheit. Here's where the math comes in. 300 psi times our derating factor of 0.42 equals 126 psi at 200 degrees Fahrenheit. Keep in mind, we're looking for 200 psi on this hose, so that's not going to work for us. The next result was the chem joint male thread, 250 psi at 70 degrees Fahrenheit. So what's the math to derate this? 250 psi multiplied by our derating factor of 0.42 is 105 psi at 200 degrees Fahrenheit. Well, we can't use that one either. I hope we have some better luck on the next one. Long criminology nipple, rated at 500 psi at 70 degrees Fahrenheit. And our math, 500 psi times 4.42, our derating factor, gives you 210 psi at 200 degrees Fahrenheit. That's our winner. We needed 200 psi. We can use the long criminology swivel at 200 degrees Fahrenheit and still be at 210 psi. And there's just one more thing, is to make sure your hose meets the temperature and pressure requirements as well as your fittings. Next slide, please, Rob. So this is a little bit of repetition, but we're going to do a few more just to make sure everybody is comfortable. So case number 3, we're going to look at a 3/4 inch steam hose rated at 250 psi. The coupling attachment is going to be our Campbell Fittings Biton Seal ground joint with a staked-on ferrule, which is rated at 1250 psi at 70 degrees Fahrenheit. In this example, we're going to be using steam, which is going to be at 406 degrees Fahrenheit, and the pressure is going to be 250 psi. So first thing we need to do is find our derating. So what is our derating factor? Again, we're talking about a steam hose. So we're going to read across steam hose, 150, 200, 250, 300, 350, 400 degrees Fahrenheit. So 406 and 400, we're going to allow you to use the same derating factor for that, and that's going to be 0.20. Could you advance, Rob, please? Our derating factor is 0.20. So then we're going to do our math for our hose system derating. 0.20 times the 1250 psi on that Biton Seal ground joint gives you 250 psi at 406 degrees Fahrenheit. Again, it's simple, just repetition. And one more time, just to make sure we've got it all down. Case number 4. We're going to look at a 3-inch air hose rated at 500 psi. This particular coupling is going to be a long shank crimpology nipple with a long ferrule rated at 600 psi at 70 degrees Fahrenheit. So our operating temperature is 150 degrees, and we have an air hose. Again, we're going to be dealing with all other, which would be chemical, air, rubber. So we're not dealing with 70 degrees. We're going to follow along until we get to 150. We follow the intersection, 150 with all other hose is a 0.64 derating factor. And now we do our math. 0.64 times 600 is going to give us 384 psi at 150 F. So that 600 psi fitting is going to be rated at 384 psi at 150 degrees Fahrenheit. Next slide, please, Rob. Courtney, we have our poll question, please. So, how useful do you think the Campbell Fittings Coupling Selection Guide will be to you and your business? I don't think it's just all for the newbies. I think it can be useful for a lot of you. So please select one, very useful, somewhat useful, or not at all useful because I don't care about safety. See if we can tabulate some of the votes here. Just give it a couple more seconds. And hopefully everybody's had a chance to vote. Can we reveal the answers? All right. I appreciate that, folks. I'm glad you found this useful. And I'm sorry for the technical difficulties we had at the beginning. We had a thunderstorm down here in Jacksonville, Florida, and I think that probably had something to do with what happened. But we can advance to the next slide. Looks like the poll is still up there. Rob, can we hide the poll question?
I think we're stuck, so hold on one second. I'm working it on my end.
Okay. So I've listened into a lot of our webinars, and this is the first one we've had difficulties with, folks. But we're getting it. By the way, 91% of you found it very useful. I appreciate that.
Sorry, everyone. I don't know why it's stuck on the poll question. Playing around with it over here.
I think everybody will have an opportunity after they get off this call. If you go to our website and get yourself that coupling selection guide, pull down the dynamic force chart and the flow rate chart, all useful tools in our business that'll benefit you in the future. Let's see. Let's see if I can transfer the presentation over to my computer. That might help us alleviate this problem. Here we go. Can everybody see that now? Hopefully. I think we're gonna.
Yes,
I think we're
we see
good.
that. All set.
So how can you reduce? Thanks, Courtney. So how can you all reduce your liability? Well, number one, use Campbell Fittings Crimpnology system. Use our coupling selection guide to find the right fitting for the job. Match our coupling selection guide to the stamp data, including any temperature derating. Use our fittings, use our ferrules, and use our crimp specs. If you verify that your final crimp is within 10/1000ths of an inch, you're going to have a successful hose system. We know our system works. We have hundreds of tests to prove it. When you use our system, you're making a measurable, repeatable, high-performance hose system. We are the leader in hose system technology. So, other than technical difficulty questions, because this is the time for questions and answers, and hopefully we've kind of scared up some ideas, and you might have some questions for us. So, go ahead and type them in and send them in, and we'll see what we can do to answer those. Sometimes when I do this presentation, I get asked, how are the derating figures devised? How do you calculate that? Well, I'm sorry. I'm sorry. People ask me how the derating figures are devised. Our derating chart is proprietary. However, I can tell you that it's a combination of engineering formulas and empirical evidence based on our testing that we have done over the years. And Courtney's telling me that we don't have any questions. That must mean that the presentation was successful and you all learned everything you needed to learn. We will be sending out this webinar through email, so all of you that have signed up will get a copy of this. And feel free to fire off any questions to me or your regional sales manager, and we'll make sure we take care of those for you. Good luck, everybody. Oh, wait.
We got some last minute questions, so let me read those off to you. Thank you everyone for sending things in. Here's our first one. Should you use the 384 rated fitting in example number 4 in the 500-pound hose? Please advise.
You should use it in a 500-pound hose, but you should also make sure that everybody knows that that 500-pound hose is no longer a 500-pound hose. It's 384. The problem is if you try to do that with a 300-pound hose to make sure that your fitting is better than or equivalent to the hose, you may have issues with the hose not meeting the requirements.
All right, next question. Why is derating figure applied to higher connection rating rather than hose rating?
Well, the derating is all about the fitting staying in the hose. So that is what we're derating. As the hose experiences higher elevations of heat, higher temperatures, the compound starts to change, and our fitting, being whether it's crimped or clamped onto that hose, is going to have difficulty staying inserted in the hose. So what we are derating is the attachment. We're derating being able to keep that fitting in the hose. We're not derating the hose. Hope that answers the question.
Yep, and that's all of them.
Okay, Courtney, thank you. Again, everybody, thank you for joining us. Hope you can check out more of the webinars. And again, I apologize for our technical difficulties at the beginning, but y'all have a great day.